Hello and welcome back to the lab. Today on the bench we have something that is large, highly useful, and right now being a pain in my butt. This is my dim bulb tester. I actually had some questions on this on the channel, and somebody asked me if I would go through what I was using for a Variac isolation transformer and dim bulb tester. This is the dim bulb portion. So essentially we have 6 sockets, 7 switches, and a power connection box down here. We have a standard mat that I keep on the bench, anti-static mat for scale. This thing is rather large, and that's what's actually causing me some heartburn at the moment. It can't shrink much because this coupler, these 2 couplers are actually touching. There is a piece of conduit in there holding everything together, but they are literally touching all the way down, so I can't shrink this up and make it any shorter. The other problem is I do kind of need it to be this large. I work on some high current stuff, especially with scopes and a few other things, like one of those tech scopes. It can draw 5, 6, 7, 800 watts. And on a standard 1 or 2 bulb dim bulb testers, I was kind of just overloading the bulbs. And because the scope was drawing so much current, even though there was no faults, the bulbs were going kind of sideways on me. So construction-wise, this is all electrical equipment. So electric conduit, electric 110 rated cable, covers on all the switches. These are actually 20 amp switches. 20 amp is overkill for this. 15s would have been fine, but 20 amp was what I had, and that'll just give it some more longevity. And it's a piece of safety equipment, so I tend to overbuild those a little bit. I do hit the safety drum a little bit hard in the lab. The reason is I used to work on some equipment that if anything went sideways, I wasn't going home. We'll just put it that way. I worked on some systems that were incredibly large, both mechanically and electrically, and had enough energy behind the electric components of it that one would rapidly cease to be. And I'm not talking just getting electrocuted. I'm literally talking being just vaporized by the arc. So I do take the safety side of the lab a little bit serious. In a previous video, I got called out for fear-mongering and a few other things. It's not fear-mongering. It's a healthy dose of respect. I respect 120. I respect 240. I respect 480. I respect it all. Because 120 is enough to do someone in. The difference between 120 and 480 is 120 is going to hurt for a lot longer. So I don't want to get hit by any of it. So I'm just careful. The other problem with that is, and one of the reasons why I do have to hit the safety side of the equation a little bit hard, I'm a guy on YouTube and a whole bunch of people see my videos. The problem is I don't know what the viewer's experience level is going to be, and it could be something brand new. This actually happened at a event I was doing recently where there was a very enthusiastic young engineer, extremely young engineer, who was barely past blinking lights with Arduinos and was wanting to play with microwave oven transformers. We had some conversations and helped push in a slightly more appropriate direction, albeit saving the microwave oven transformers for a little bit later. So I'm out and about and I run into this stuff all the time. And I have a healthy respect for anything that can put me underground. And my goal is to stay above ground for as long as possible. So it's not fear. If it was fear, I wouldn't even do it. And I mess on some stuff. I play around with some stuff that's well into the KV range, and definitely hurt the technician, definitely hurt the equipment, and you just have to take care. So that's kind of where the safety aspect comes in. Hence the reason for the dim bulb tester. Keeps stuff from exploding on the bench. So the bulbs that I picked for this particular dim bulb tester, obviously they can be changed out to increase the current available, were these decorative 60-watt Edison bulbs. And 60 watts a nice good number because every 60 watt light bulb is about a half an amp. So if I have a line of 60 watt light bulbs, I can switch in to, now I've got an amp, roughly an amp available. So this will actually source up to 3 amps of 110 without the bulbs lighting up and going into current limit mode. 3 amps is a decent amount of power. It's still not enough for a 500 series scope. Well, they're 5 to 800 watts. But 3 amps and a switchable 3 amps I found is good for the majority of things that I work on. Now, the big problem right now is I don't know where I'm going to put this thing. Again, it was hiding out over there off camera, and its space got gobbled up by a shelf. So I truly don't know where I'm going to stick this thing where it's useful for the lab. I may have to move a shelf and make a board and get this thing mounted again, but I do need to get this back into service before we do too much additional repair work and testing. But this is one piece of the Variac and dim bulb tester and isolation supply. The Variac hides right here in a corner, and this is a Circuit Specialist Variac. Model number actually is right there. So this is an older one. It has the meter voltage here, or the voltage sourced at this plug on this meter, and the new one, I believe, has voltage and current, which is kind of nice. I'd like to see voltage, current, and watts, but voltage and current is a good place to start. Circuit Specialist also, I don't know how they do it, but they seem to have cornered the market on the high current Variacs. This is actually a 20 amp model, and their 20 amp model is relatively inexpensive. For a high wattage Variac or a high amperage Variac, you can get... they get kind of pricey pretty quick. So they can do 20 and 30. The 30s actually have banana terminals on the front. The 20s actually have a standard plug. And this one is the 2000 VA transformer. 20 amps at 2000 VA, assuming a power factor of 1, is the rough math calculation. In front of that, we have the triplet 660, which is hiding just here. This is a faster responding meter than what's on the Variac. Here's the triplet. This is a volts and watts meter, a little dusty, but it hangs out over here in the corner. And I'll watch this as I am rotating up the Variac knob, so I can watch this climb and I can watch the current draw climb. If this shoots to the moon, obviously we'll back off and not blow anything up. This is a 2-pin device, so I do have a 2 to 3 pin adapter, which is fine because the next stop is the isolation transformer, typically. So when I had this all wired in, coming out of the Variac was the bulbs. That went into the triplet because that gave me an accurate, somewhat accurate voltage reading of what was coming out through the bulbs, and a watts reading as well. The thing that I do not like about the triplet, and I really, really, really want to find one, is I don't like it that it has to be in this orientation to read correctly. I'd rather it be standing up and I can look straight on in the face while I'm dialing the Variac around. But I am stuck with what we have, and this is what we have. This is what was made. But to get these meters to read right, it has to be on its back, and you have to look down on top of it as opposed to straight on this way, which is what I would personally prefer. And I'm working on figuring that out. If anybody has a idea of a unit that does this function that's a straight on, let me know, and we'll see what we can do. Coming off the back side of the bulbs, coming in right here, is this monster, which is the isolation transformer. This is a medical grade isolation transformer from Toroid. The model number is an ISB 100W. That model number is a little misleading due to the fact that it is a 1000-watt isolation transformer as opposed to a 100-watt isolation transformer. So I don't know why they made it 100W, but this is actually a 1000-watt transformer, or a 1000 VA transformer, I should say. And I just noticed these markings are different. So this one specifically says output current 8.34 amps or 4.17 amps, 100 VA max. Down here, it says the same thing, except it says 1,000 VA max. So it is a 1,000 VA transformer. I have driven this at 8-ish amps before. So it'll hold up. And I needed the isolation transformer of this amount of current. And this is about the smallest package an 8 amp transformer gets in. And there's my hand on top. So nice big toroidal transformer in here. Huge thing. But also heavy. There's some gravity in this one. But the smallest package that I could get 1,000 VA in, and there's one of these tucked underneath the bench. I had another one. This is the 230 volt, which I haven't had to work on much 230 volt stuff recently. So this will actually take 120 in and step it to 230 volt phase to neutral. So where I am in North America, we have 240 volts, but we do not have 240 volts phase to neutral. We have 240 volts phase to phase. It's actually the same phase. It's just a center tap off the transformer on the pole. So it's end to end. But the problem is if you get a straight 230 volt device, some of them don't care. A lot of them care if they're wired end to end like that, and they get kind of cranky. So always best to follow the guidelines in your local municipality, electric code, and all of that good stuff. Remember, I am a guy on YouTube. I am not an expert, and I am specifically not an expert in your area. One other thing that's highly useful on this output transformer is I have 1 in, but I have 9 out. So these are standard computer power cables, just a reverse. So they'll take PDU cables from server racks. They can go in here, and that can give you an end, or it can give you a this end that you could plug in, just a regular old computer power cable, NEC connection. Which is what I've done, and the nice thing is the transformer that's underneath the bench drives 3 power strips on the workbench. So there's that black APC power strip that's way back there. That's one. And then on each leg of the bench that I sit next to, one's about right here, the other one's over here. There are 2 more power strips that are driven off of this transformer. I don't necessarily need that many plugs that are on the isolation transformer. However, it allows me to have a protected outlet that's on the testing supply, depending on how big of something I'm working on. If I have a giant scope or something on the bench, I can run the power cord down here and have somewhere to plug it in, and I don't have to go all the way back here, go over the device I'm working on, things like that. So I have found it very, very useful, quite situational, but very useful to have more than one place to plug in the isolated supply, and that has proven quite useful. Now, because we are dealing with a bit of current on this particular unit, everything was done with 12 gauge cable. We have some nice, I believe this was 12. Oh no, 14, sorry. 14 gauge cable, because it's only going to see 3 amps, and that's fine. Nice beefy plugs though, in and out. So this goes into the Variac, the triplet comes out of this, and the isolation transformer goes into the triplet. All right, so what is the schematic for this kind of monster dim bulb tester thing that I've built? It's actually relatively simple. We have 2 connectors, which are these guys right here, and those show up right here. And then for the bulbs, there's a switch and a bulb for each position, and that's on the line side of the power. And then there's a bypass switch that just switches out all the bulbs and gives me full line current through to the device under test. So essentially what that looks like is each switch, these are all wired in parallel. So as I flip them on, you'll have a path down, up, and then back down. And then this is the bypass switch. So If I want to just put full line voltage across and not and switch out the current limit, just flip that switch and it hits the device under test with a full line voltage available in the lab, which does run around 20 amps. These are 15 amp cords and plugs, given that these are 14 gauge. And if I ever needed more than 15 amps on this, I could easily swap these out, get some new plugs. If I'm doing devices under test that need more than 15 amps, I'm doing special cable anyway. That's getting into some of the significantly heavier pieces of equipment when you start drawing 20 amps plus. So this is fine for the dim bulb tester. Also, the Variac tops out at 2000 VA. So the weak link in all of this is actually the isolation transformer itself, because the isolation transformer is only good for 1000 VA. This is completely fine as built. This will take anything the isolation transformer will, and I'm just careful not to burn down that isolation transformer because that is not cheap to replace. So, thanks for stopping by the lab and taking a look at the dim bulb tester video. If you're liking what you're seeing, hit all the YouTube buttons, like, subscribe, and bell, and let me know how we're doing in the comments section. If you have any questions about the video or anything that I've said, hit me up in the comments. I read all the comments in between videos. And if you'd like to support the channel, check out the Patreon page. Patrons are running a little bit ahead of the YouTube releases, at least as the recording of this video, and all their support goes back into the channel, making videos for all of you guys. Their support to the channel cannot be understated, and I cannot thank them enough for helping me bring videos to YouTube. So thank you again to all the patrons that support the channel, and as always, I will see everybody in the next video. Bye for now.